What?
Hey, Sarah, did you mean to turn in yesterday's homework or today's?
I meant to turn in yesterday's homework, not today's homework.
All right, so you put it on today's homework. You put it on 9.5b. I figured as much. So did Piper. She did the same thing.
Wait, Leah. Yes, we'll just read this. Huh?
Haley, did you get your issue fixed or is it still messed up?
What do you mean?
Didn't you send me something that you couldn't see the assignment?
Oh, yeah, the math assignment. I haven't checked it.
Check it at some point and then send me back if you're still having issues. Because according to mine, you're on the list. You should be able to see it. And I didn't really change anything, so it should be okay.
I haven't checked it since I left, but I will probably try again.
All right, 11:25, time to go. All right, so we're in the meat of the challenging stuff. All right, your goal right here is to, I don't want to say survive, but your goal right now is to trust the process, trust the fact that we're going to do many examples here. Today's just a practice day, but today we got to make sure that we hammer this hard in understanding the procedures and try to get into the right answers. All right. Any quick questions anybody has before we get started?
I'm here.
Okay. No. All right. So we're gonna get started. All right. The first thing we're gonna do is we're gonna go over the answers. So 1 through 12 all. Check your work. If you get, I would say, more than 3/4 of these correct, then you're solid, right? If you don't get at least half right, then we got big issues. All right, but those issues will be addressed today when we do more practice. All right, number 1. Now, I'm going to call it out in a specific order, but the order can be reversed. So, for instance, the answer to number 1 is the quantity 3x plus 1 times x plus 2. Now, if you wrote x plus 2 times 3x plus 1, that's fine as well, too. All right, I'm only going to call it one way. Number 2, 2x plus 3, x plus 1. And we get kind of lazy in Algebra 1. We tend to, when we're calling out answers like this, we leave off the parentheses, but the parentheses must be there. So for question number 2, it should be the quantity 2x plus 3 times the quantity x plus 1, but we get lazy when we call out the answers. All right, number 3, 3c minus 5 times c minus 1. Number 4, 2x minus 1 times x minus 7. Number 5, 5y minus 1 times y plus 1. Number 6, 3a minus 2 times a plus 2. Number 7 is not factorable. Number 8 is 3r minus 5 times r plus 1. Number 9 is 7x plus 1 times x plus 1. Number 10 is 2p plus 1 times p plus 3. Number 11 is 5x minus 2 times x minus 3. And the last one, number 12, is 7m minus 2 times m minus 1. Any questions on that?
What was 5?
Number 5 was 5y minus 1 times y plus 1.
Can we go over 5?
Sure. Let me pull up a sheet of paper here. Here we go. This would be number 5. So number 5 starts off with 5y squared plus 4y minus 1. Plus 4y minus 1. So plus 4y minus 1. Okay, step number 1, we figure out what's a times c. 5 times negative 1 -5. Stop me if I go too fast. So now we're going to think about -5. Give me two numbers that multiply to give me -5. Anybody?
1 and -5.
1 and -5, and 1 plus -5 is -4. So that's not what we're looking for. We're trying to get to a +4, but that gives us the clue that it's probably
-1 and 5.
perfect. All right, because 5 minus 1 is 4. All right, so we just found the two numbers whose product is -5 that add up to the b value here, 4. So what I put there in the little rectangle right there is how we're going to rewrite our problem. So we write 5y squared. If there's one's negative and one's positive, we like to write the negative first. -1y, we're not an x this time, plus 5y. Where did I get the -1 and the 5 from? Right here in the box. And then lastly, -1. So all I did was write the original trinomial, this one right here, in this manner right here. The reason we do this is because it makes our life easy. I know I was taught the guess and check method. Your parents, your older brothers and sisters might have been taught the guess and check method. The guess and check method does work. The issue with guess and check is that it's guess and check, right? It's not, you can guess all you want, you might not guess the right answer. But this method right here gets us to the correct answer every time. So the next step is we do parentheses, 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 right? It's basically an associative property right here. And then we're going to factor out common factors. So I'm going to look at this first binomial right here. Clearly it's got a y. The first term has a 5, the second one has a 1. There's nothing common between 5 and 1. So the only thing I can factor out of this first binomial right here is a y. If we factor out a y, we'd be left with 5y. The way that I think about this is what times y is 5y squared? That would be 5y. Y times 5y is 5y squared. What times y is -1y? Well, -1. So -1. So if you're trying to think, I mean, there's two ways of thinking about this. You either divide both terms by y, the common factor, or you think about it as multiplication. I'm kind of more of a multiplication person. What times y is 5y squared? 5y. What times y is -1y? -1. We do the same thing to the second binomial, this one right here. There's nothing common here, at all. But remember, 1 can always be factored out of anything. So when nothing is common, I mean, there's 5 and 1, there's nothing. Y, this one doesn't have a y. So the only thing common is a 1. So when we factor a 1 out, we're left with magically, check it out, 5y minus 1. And that's why this method is sweet, because it will always, as long as it's a factorable trinomial, it always gets to the right answer. And this will always match that. To get to your final answer, we factor this whole thing right here. And we write what's inside the parentheses, 5y minus 1. And then what's left is my other binomial, y plus 1. Y plus 1. Sorry for I'm doing this with a mouse. That's why it looks horrible. And that's why that's the answer. Now, you could have written this as y plus 1, 5y minus 1, or 5y minus 1 times y plus 1. Cool? I forget, who asked that question to do this?
It was me, Josie.
Josie, you got it?
Yeah.
All right, cool.
What was the answer to number 11 and 12 again?
Number 11 was 5x minus 2 times x minus 3. And 12 was 7m minus 2 times m minus 1. Okay, so we're going to do 5B or 5.9b today. Today is just a practice day. There's nothing new. I'm going to go over the class that I gave you yesterday super quick. We'll do maybe 2 examples or 3 examples. And then what I'd like is for those that like, okay, I got this, I don't need to. You can check out. And for those of you that want to do a couple of the homework ones together, I'm not going to do them all because you do need some practice, but we could probably do 3 of them together. We can either pick 3 or we'll just do the first 3. Homework tonight, it should be up right now. It's the same page. It's just 13 through 24. They don't get that much harder, like than they were last night, 1 through 12. So this is just 12 more problems. It's the same basic idea. Some of the numbers are slightly larger. If I remember right, there's one that's a little bit ugly because the number gets really large. I'm trying to look. I think 18, the number is pretty large. But other than that, they're all pretty reasonable. Okay. And remember, on the assignment itself, on Teams, you can see this. You don't necessarily have to copy this down. All right, here we go. So remember, we're factoring trinomials where the a value is not 1. Generally, what happens is I'll teach this class, and kids will get pretty good at this technique, and then they will forget the simple ones. This is one of the simple ones. Notice the a value here is not 1, or the a value is 1, sorry. In this case, then all we do is we think about C and B. We think of what two numbers multiplied is -12 that add up to B, in this case 4. So those two numbers would be 6 and -2. 6 plus -2 is a +4, and 6 times -2 is -12. So kids will forget this entirely. The one cool thing is that you can always solve the technique we're using right now, the more complicated one. It will also work for these easy ones. It's just too much work. I mean, you can factor this one really quickly using the old method. All right, so once again, the magic, so to speak, is you think about what are the factor pairs of -12 that add up to the b value, in this case 4. And so these two, 6 and -2, are the quantities that you put into these two binomials right here. All right. When a value is not 1, so here's one where a value is not 1, that magic doesn't work anymore. Check it out. There's only 2 numbers that multiply to 7, but neither of those, 1 times 7, neither of those don't add to 23. So this old magic doesn't work. We have to use this new technique. So this is the wrong magic for when a equals 1 or a does not equal 1. We have to use this new technique. So I'm going to go over this really briefly, and then we'll do a couple examples. And like I said, those of you that have a good handle on this can check out, get started on your homework or whatever you want to do. The rest of you hang, and we'll just do, I don't know, 3 or 4 of the homework problems together. Okay, so here's the new magic. The new magic has steps. The first step is to multiply a times c. If you forget what a, b, and c are, just have this written somewhere in your notes: ax squared plus bx plus c. This is in standard form. So let's see, a times c, that would be 5 times a +2. 5 times a +2 would be 10. Can somebody, as I'm talking, Anna's asking for can somebody just tell her on a quick chat there just to look at the assignment? The Zoom meeting will always be, and it never changes. I don't have a different address every day. It's the same one. Anna's trying to get in. Just somebody send her a quick chat that says, hey, look at your assignment 5-9B and click on the link. Thank you. Let's see, where did I leave off? Oh yeah, a times c is 10. Step number 2 is we're looking for the factor pairs of 10 that add up to 11. So we're looking for the factor pairs of AC that add up to match B, and B in this case is 11. Well, we can go through every single factor pairs if needed, right? 1 times 10 is 10, 2 times 5 is 10. But some of you can quickly see that the answer should be the 1 and the 10. 1 plus 10 is 11. If this is factorable, one of these answers right here, 11 or 7, will match B. If neither of these, 11 or 7, matches B, then this is a non-factorable trinomial quadratic. And that will be the case. I'm looking at homework tonight. When I give you 13 through 24, there are 2 tonight for homework that are not factorable. 2 of them are not factorable. The issue is that sometimes if you don't have a good method of thinking about all the factor pairs, you can skip one when it is a factorable one. So what my recommendation is, always start with 1, then do 2, then 3, then 4, so forth and so on. Consider every single possible factor pair before you conclude that it's not factorable. Okay, so we just figured out that we want to look at that answer right there. So step 3 says that we're going to take 1 and 10, and we're going to rewrite the middle term, 11x, as 1x plus 10x. So all I did was, well, I did a times c is 10, found out the factor pairs that add up to b, and then rewrote this in blue, this middle term, as 1x plus 10x. Where did the 1 and the 10 come from? Right here in this red box. Why did I come up with those numbers? Because that is the factor pairs of A times C that add up to 11. Okay. Now I'm going to show you another step, but clearly you could put the parentheses around the answer that you just wrote, but we write parentheses, 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 parentheses. Parentheses around the first two terms, parentheses around the last two terms. And then we factor each binomial separately. So my first binomial here, generally speaking, this is where we kind of slow down. The steps up to here are pretty standard. They're pretty quickly done, but here's what yes.
Isn't this stuff we did yesterday?
Absolutely.
So why are we just relearning it, or?
Did you just pop in?
Yes.
Okay, so I said at the start of class is that today's homework is just 13 through 24, so it's just practice on what we learned yesterday. So absolutely, positively. Hang with me to the end, just confirm that you know what you're doing, and then you can punch out.
Another thing I have to say is, do you want me to send a picture to you for my homework? You just want me to send you a picture?
Yeah, remember, you're going to go on the assignments tab under Teams. You're going to click on 5.9a. Hopefully you did this yesterday, and then you attach a picture of your homework to that. The same thing tonight for homework for 5.9b. You'll attach a picture of your homework to that. Make sense?
Yeah, thank you.
Okay, so here we go. I'm going to look at 5x squared and x. I'm going to look at this number 5 and this number. Well, there's no number right here. It's 1. The only common thing between 5 and 1 is 1. But between x squared and x, there's an x that's common. So when I factor the first pair, I can pull an x out of both terms. What times x is 5x squared? 5x. X times 5x is 5x squared. What times x is x? 1. Or you can think of this in the division. 5x squared divided by x is 5x. X divided by x is 1. Either way of thinking about it is correct. Pick whichever one you like. All right, the second binomial, 10 and 2. Well, clearly 2 goes into both of them. I know it's a coincidence that what goes into both of them is one of these numbers. It won't always be that. All right, so 2 can go into 10 and 2, and there's only one x, so I can't pull out an x there. So 2 times 5x is 10x, and 2 times 1 is 2. Like I said, either think of this as multiplication. What times 2 is 10x, 5x. What times 2 is 2, 1, or division. 10x divided by 2 is 5x. 2 divided by 2 is a 1. Our final answer, the answer to our initial problem right here, 5x squared plus 11x plus 2 in factored form, is we take the common factor here. The common factor here is what's in parentheses, 5x plus 1, right? And then if we cancel both of those out, we're doing division here. We're dividing both of these terms by 5x plus 1. What's left is, well, the stuff that I didn't cross out, the x plus 2, okay? So for those of you that are like, yeah, I already did my homework last night, I got this, fine. But I know on Sierra's, when I looked at her homework, she did like the first 4, and then she was like, I don't know what I'm doing here, right? So this is the process. This process does not change, okay? Any questions? Okay. We'll do about 2 more, and then we'll get to homework. All right, so this one right here, oh, we got a negative here. It still stays the same thing, even when you have negatives. We do a times c. That would be 8 times 3 is 24. 8 times 3 is 24. The issue is that we're trying to get to a negative 14. So when we think of factor pairs, well, then we can't think of the positive ones. 1 times 24 will never, and you add those two numbers together, will never get me to a negative. The thing you got to remember is that you can get to a positive number when you multiply two negative numbers together. So negative 1 times negative 24 is a positive 24. Negative 2 times negative 12 is a positive 24. But when you add these two together, check it out. Look, I'm getting a negative number. That's how you arrive at a negative number, is when you multiply two numbers together, their sum will be negative. So negative 2 and negative 12 add up to negative 14. So those are the two numbers that I want to rewrite my trinomial by. So in this case, I'm going to change negative 14 to, negative 2x plus negative 12x. That's where I'm getting these two numbers, these two coefficients from, right here. Okay? Next step, we do parentheses, 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 and then we start to factor. All right. So this is the one you got to be careful at when this term right here is negative. When this term is positive, it works out fine. You don't have to think about it. But when this one is negative, we got to think about it. So let's see, what's common between an 8 and a 2? A 2. What's common between an x squared and an x? An x. So we can factor out a 2x from the first term. 8x squared divided by 2x is 4x. Negative 2x divided by 2x is negative 1. Or what times 2x is 8x squared? 4x. What times 2 is 8? 4. What times x is x squared? X. What times 2 is negative 2? Negative 1. What times x is x? 1. So 4x minus 1. On the second one, when this first term of the second binomial is negative, pull out a negative. So notice what's common between the two is a positive 3, right? I want to pull out a negative 3. If you pull out a positive 3, look what happens. This term right here doesn't match this one right here. So instead of pulling, and this only happens when this term, this one term right here is negative. When that happens, always, always, always don't pull out a positive, in this case 3, pull out a negative number. So when we pull out a negative number, check it out, look, it matches perfectly. Negative 3 times positive 4 is negative 12, and then just an x there. So negative 3 times a positive 4x is negative 12x, and negative 3 times a negative 1 is a positive 3. Now, both binomials match. Final factor form, we take out the 4x minus 1, and what's left after that goes away is 2x minus 3. Hopefully by now you're seeing this pattern. Any questions? All right, for those of you that are still with me, we really need to do 2 of these together. So we'll do these 2 together, and then I'll let you go your merry way. And if anybody wants to hang and do homework, I'll do the first couple with you together. But I do want, for everyone that's still here, I want you guys to do these 2 with me. I mean, like you're writing down the answers as we do them. Okay, we'll do the one on the left first. So pencil, paper, here we go. So write 3x squared minus 11x minus 4. Step number 1, A times C, 3 times negative 4, 3 times negative 4, 3 times negative 4. Chris, are you still with me? 3 times negative 4? Chris, are you listening? So, okay, so the answer is, you can hit the space bar to take you off of mute. Just hold down the space bar and talk. I see him talking, but I don't. All right, 3 times negative
I don't know.
3 times negative 4 is negative 12. All right, so that's your first step, negative 12. 3 times negative 4 is negative 12. All right, now we're going to think about factor pairs of negative 12. Now, if this number is negative, the only way you get to a negative is a positive times a negative. We're trying to get to negative 1 right here. So let's see, what numbers multiply together is negative 12 that add is negative 1? Well, I can think negative 1 times a positive 12, but that will get me to a negative 12. But those 2 numbers added together would give me a positive 11. Well, check it out. I just need to make it 11. So maybe if I flip-flop these signs, all there. So what's who was that? All right. 1 plus negative 12. Who's got their speaker on?
Someone
Chris.
Ether says.
All right. It's always Chris. All right. 1 times negative 12, negative 12. 1 plus negative 12, negative 11. Negative 11. So this is how I'm going to rewrite it. Now, be careful. One of them is positive, one of them is negative. Save yourself some effort. One's positive, it's one negative. When you rewrite this trinomial, put the negative 1 first. If you put the negative 1 second, it'll still work, but you'll have to pull out a negative out of the second binomial. Okay.
Is there a hole in it?
All right. Hey, Aiden, let's pay attention, please. All right.
My stupid brother's doing something, so I'm paying attention.
Close your door. All right. Second step after we have this written right here was you do parentheses, 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 parentheses. Now, I wrote it as a second step. You can certainly put parentheses around this one. Now we look at each one individually and we factor each one. I know Julie made the comment, yesterday, she was like, you're always going to pull out an X out of the first one. Yes, or a Y or a Z, whatever the variable is. So on this first binomial, you're always going to be pulling out an X, and then whatever's the common coefficient. Well, 3 and 12, what goes into both 3 and 12? A positive 3. So I'm going to pull a 3X out of the first one. 3X times X is 3X squared. 3X times negative 4 would be negative 12X. 3 times negative 4 is negative 12. And there you go. Out of the second one, there's nothing common between the two. When there's nothing common, always pull out a 1. 1 times X minus 4 is X minus 4. And from there, we get to our answer really quickly. X minus 4 times 3X plus 1. Questions? All right, the last one is kind of easy. Go ahead and write it down. 6X squared plus 17X plus 5. 6X squared plus 17X plus 5. Okay, A times C, 6 times 5 is positive 30. Notice our middle term is positive, so we only need to consider the positive values. 1 times 30 is 30, but 30 plus 1 is not 17. Let's see, what would be the next thing considered? Oh, 2 times 15, right? 2 times 15 is 30, and 2 plus 15 is 17. Okay, that was pretty simple. Right? Even though these numbers are large, sometimes you can get to the answer pretty quickly. All right, anyone lost on what I'm doing here in this process right here? Like how I'm getting these numbers 2 and 15, 1 and 30? Okay, this process has to continue until you get a match. If you never get a match, let's just say that this middle term was 15x. If the middle term is 15x, this would be a non-factorable trinomial. But in this case, it's not 15, it's 17x. All right, we're going to rewrite this whole trinomial using these two values right here for our middle term. So we're going to write this as 6x squared plus 2x plus 15x, and then add on the plus 5. Okay? Parentheses, 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 parentheses. Now we look at the first two coefficients, 6 and 2. What goes into 6 and 2? A 2. What goes into x squared and x? An x. So 2x is what I'm going to pull out of the first one. 2x times 3x is 6x squared. 2x times 1 is 2x. Out of the second one, we got a 15 and a 5. I can pull a 5 out of both, right? 5 times 3x is 15x. And a 5 times 1 is 5. Even though this one had large numbers, it ended up being not too challenging. Okay? All right. So this turns into 3x plus 1 and 2x plus 5. All right. Any questions?
None.
Cool. All right. So practice. So here's the deal. For those of you that want to hang and do the first, 2 or 3 problems for homework together, hang. For those of you that want to punch out, then that's all I have for you for class today. Let's see. Where's my? We got about 20 minutes left of class. So it's up to you. If no one hangs around, then I'm going to punch out. And if you want to hang around, then we'll just start doing the problems together. And since I see a whole bunch of people staying, then we'll just do a bunch of these together. All right. So here we go. We'll start off on number 13. So on your papers, let's see, 3p squared. I wish they would always use x. It would make our lives easier. Plus 7p minus 6. Okay. Step number 1, a times c. What's a times c? Somebody yell it out.
Negative 18.
Negative 18. So we're trying to get to negative 18 using two numbers that add up to positive 7. So, here's my thought process. 1 times 18, even before if I consider one positive or negative, there's no way that these two added together, whether one's positive or negative, do we ever get to a 7. So I'm not even going to worry about 1 and 18. My next possibility would be, 2 and a 9? And if you notice, a 2 and a 9, you can get to a 7 if you subtract, right? The question is, we need 7 to be positive. If we make the 9 negative and the 2 positive, 2 minus 9 is negative 7. So what do we really want? We want the 2 to be negative and the 9 to be positive. And that's what will add up to this positive 7. Everybody with me? So that's my thought process. If those two numbers didn't work, then I would go to 3. 3 times 6 is 18, and consider that. Okay? All right, if none of those numbers, by the way, it would either be 1 times 18, 2 times 9, or 3 times 6. If none of those numbers work to get to 7, then we would conclude this is not factorable. In this case, it was, so we've got our two answers here. One's negative, one's positive. We're going to put the negative one first. So we write 3p squared minus 2p. I got that from that number right there, plus 9p. I got the 9 from right above. And then the last part is minus 6. Okay? Questions? Parentheses, 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 parentheses. We look at the first two numbers, a 2 and a 3. What goes into 2 and 3? Nothing besides 1. What goes into p squared and p? A p, right? This is always follows the same pattern. You look at these two numbers, we'll go, I guess you could put a 1p there if you wanted to, right? All right, we're going to factor out a p. We factor out a p, right? If you think about this as division, you'd be left with 3p. If you think about it as multiplication, what times p is 3p squared? 3p. P times 3p, 3p squared. If you think about it as division, you're dividing that number by p. We do the same thing with the second term, negative 2p. What times p is negative 2p? Negative 2, right? Or if you divide a p out of negative 2p, you're left with just negative 2. Either way works. If you have to confirm, you use the distributive property to make sure you get back. This times that is that. This times this is this. Okay? Second one, I got a 9 and a 6. 9 and a 6, well, there's a 3 that you can factor out of that. 3 goes into both 9 and 6. Only one of the terms has a p, so notice it will follow the same pattern each time. The second one will not have a variable, the first one will. We factor out a 3, we're left with 3p. In other words, what times 3 is 9p? Well, that would be 3p, or 9p divided by 3 is 3p. What times 3 is negative 6? Negative 2. Or negative 6 divided by 3 is negative 2. Hey, look at this magic here. We always get, if it's factorable, we always get the same darn thing. I mean, this could be a key that if you don't get the same thing, you've done something wrong. As long as you found two numbers that add up to that, multiplied together, that are a times c. Okay, final answer. And it doesn't matter the order that you write this. I always write the parenthesis one first, but you can write the other one first as well. And then in the second set of parentheses, you put what's left, that number and that number, p plus 3. And there you go. You have now completed number 13. Questions? All right. I said we do about 3 of these. There's one. Let's do another one. No one has a question, correct? All right. So number 14 says 4c squared, 4c squared plus 4c and minus 1. All right. Step number 1.
It's minus 3.
It's minus 4. 4 times negative 1 is negative 4.
Mr. C.
Oh, I see what you're telling me. All right, I'll pay more attention this time. All right, a times c, negative 12. Okay. Okay, we got to think of factor pairs of negative 12 that add up to positive 4. Well, I mean, I guess I could think about 1 and 12, but once again, that I'm trying to get to a positive 4. 1 and 12, no way. Add or subtract, we don't get that. 2 and 6. Oh, 2 and 6. 2 and 6. Yeah. we could get to a positive 4 through subtraction. 6 minus 2 is positive 4. See, that's 6 minus 2, positive 4. So that's how quickly you can get to these factor pairs as long as you do these in a logical way. The other possibility would have been a 3 and a 4, and no way does 3 and a 4 add up to positive 4. Okay, so we rewrite the polynomial, trinomial, quadratic, and remember one's negative, one's positive. We're going to put the negative 1 first with the variable plus 6c and minus 3. Okay, stop me if I'm going too fast. Parentheses, 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 parentheses. 4 and a 2, I can pull out a 2. C squared and a c, I can pull out a c. What times 2c is 4c squared? 2c. What times 2c is negative 2c? That's a negative 1. 6 and a 3, the only thing that comes out of there is a 3. If we did our math right, we should get 2c minus 1. 3 times what is 6? That's a 2. 3 times what is a c? C. And 3 times what is negative 3? Negative 1. Hey, look, exactly the same thing. That's why I call this magic. Final answer, I always put what's in parentheses first. You can put the other one if you choose to. And then what's left, what's outside the parentheses, 2c plus 3. Those two numbers, or those two binomials multiplied together, ends up being that sucker right there. Questions? All right. Somebody choose one. So we got 15 through 24. Which one looks hard?
15.
15? Yes? 15?
Yes.
Okay, 15. So 15 is 4y squared minus y. And remember, if it just says minus y, there's really a 1 right here, right? Minus 3. Okay. A times c, oh, we got our friend negative 12. It's literally the same problem as last time, except slightly different because our middle term here is, well, there's no number here, but we could put a 1 there if we wanted to. So we're trying to get to negative 1. It's not 1 and 12. It's not 2 and 6. It's got to be a 3 and a 4. We're trying to get to minus 1. So the only way you get to a minus 1 is when the 3 is positive and the 4 is negative. Negative 4 plus 3 is negative 1. Everybody see how I did that? Okay, now clearly, I mean, I'm good at this, so I can do it quicker. It's going to take, you may have to go through every single possibility, right? 1 and 12, 2 and 6, 3 and 4 to figure this out. But once you see the answer, you can speed things up by just using a little bit of logic. Okay, if we're trying to get to a 1, I'm not going to consider 1 and 12 or even 2 and 6. All right, so we rewrite this as 4y squared. One's positive, one's negative. I'm going to write the negative 1 first. Not because I must. It just makes my life easier. If you put the negative 1 second, I'll show you here at the end here what it would look like. Plus 3y and minus 3. Parentheses, 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 parentheses. Hey, a 4 and a 4. Well, that's clearly a 4. Y squared and a y and a y. What times 4y is y squared? A y. What times 4y is negative 4y? Minus 1. A 3 and a 3, we're going to pull out a 3. And I mean, I don't really even need to do the work. I know it's going to be y minus 1. What times 3 is 3y? Y. What times 3 is negative 3? Negative 1. And like magic, we got the same thing. So you get y minus 1. And what's outside, 4y plus 3. Make sure you don't forget to put them in parentheses. My handwriting is getting horrible as we go along here. I promise you I said I would show you what would happen if we did it in reverse. So if we wrote 4y squared, and if I wrote the positive first, plus 3y, minus 4y, minus 3, we're still going to get to the same thing. It's just going to be a little bit uglier. Parentheses, 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 parentheses. 4 and a 3, nothing, but y squared and y, we get a y. A y comes out. Notice over here, a 4y came out. So it looks like we're going to get a different answer. It won't be. What times y is 4y squared? 4y. Or 4y squared divided by y is 4y. Plus, what times y is 3y? 3. 4y plus 3. Hey, notice that's this answer right here. Things just flip around. -4 and a -3, the only thing comes out is not a positive one. When this term right here is negative, always pull out a negative number. So I'm going to pull out a -1. That's the only thing common between a 4 and a 3 is a 1. But since this is negative, I'm going to pull out a -1. -1 times 4y is -4y, and -1 times 3, +3, is -3. Notice I got a 4y minus 3 and a 4y minus 3. So we get 4y minus 3 plus 3. Sorry, I said minus, plus 3. And on the second one, what's left? Y minus 1. So all we did was just get it's not the opposite answer. We got the same thing, just in a different order. This one has a y minus 1 first. This one has a second. Either one's fine. Because remember, multiplication is commutative. Okay, I promised you 3. I gave you 3. You guys have, what, 9 problems left tonight for homework. Of those 9, 2 of them are not factorable. So you have 7 that you got to factor, and you got 2 that are unfactorable. Okay, any questions? And we got 10 minutes left of class. Okay, no question. I'm going to close it right there. Good luck with your homework. If you have any questions, send them to me. I know I have a break from next period, so I can answer them really quickly. Then I got to teach a class, and then like starting student advisement period, then I can answer questions as well too. Make sure you don't forget to attach a picture of your homework to your assignment. And if you run into any problems, send me a chat or an email. Haley, where are you at right now, Haley? Oh, Haley just checked out. Okay.
She's in a car.
I know. That's what I was wondering. I was like, are you going
Yeah,
to a drive-through? Get me some French fries.
My family does
Oh, go.
my family and I do a wood
Aaron
business.
Kolinsky.
So
No,
I'm with them right now doing this. So
Yeah.
that's why every other time that I've missed the call, I've
Hi,
been here doing this.
Got it. And Harley is in, looks like you have blue lights going on here. All right, we'll end it right there. You guys have a good day. And if you run into any problems, send me a message.